Emily, Courtney can present on that. I give her the option of this one or ANOVA later, but it's good to do it now. The next homework would be due in a week, and then we'll check the schedule, and somebody else will be presenting either in a week or in 2 weeks, depending on how things go. So, without further.
So I did mine on the FBI data, and I know Professor Larson had uploaded the code to Canvas, so I didn't include the code in my project since it's already there. So some of the questions I focused on for the project were, how did the robbery and motor vehicle crimes compare in 2015 and 2016 across the regions, and is one more prominent than the other? There were a bunch of different crimes available, but I just narrowed it down to 2, and I thought robbery and motor vehicle would be the most interesting to choose. So for robberies, I did the box plot for 2015 against the regions and 2016 against the regions, but then I did a scatter plot of 2015 and 2016. So as we can see, it's broken up into Midwest, Northeast, South, and West regions. And 2015 and 2016, the graphs are basically the same. So just by looking at those, you can kind of tell the data is roughly the same. And looking at the scatter plot, you could basically draw a straight line. So there's like a positive relation between the X and the Y axis. And similarly for motor vehicle crimes, once again, the graphs are kind of the same. If you look at the South, there's 2 outliers in 2016 and 3 in 2015. But once again, you just draw a straight line for the scatter plot with the positive relation between the X and the Y. But the plot points are way closer together towards the beginning of the graph, whereas in robberies, they were more spread out across the line. We don't see that as much with the motor vehicle crimes. And just some observations between the 2. So one thing that was interesting is the axes are, the scale is different for robberies and motor vehicles. So if we look at robberies, the scale is 20,000 and 40,000, but looking at motor vehicles, it starts right off at 50,000. So this leads us to believe that there's way more motor vehicle crimes than there are robberies. In this data set, there were 52 states / locations included, the 50 states plus the District of Columbia and Puerto Rico. And I broke up the regions and how many states there were per region. So the South has the most with 17 states, but I looked back at the data and it doesn't seem to have that much of an effect on what the graph looked like. So then I did paired t-tests for motor vehicle crimes and robberies. So this is the one for motor vehicles, and as we can see, the p-value is really small since it's in scientific notation. So we do reject the null hypothesis of no difference because it's way smaller than the usual alpha equals 0.05. And for the motor vehicle crimes in 2015 and 2016, the confidence interval is also, both the numbers are negative, which means that the number of motor vehicle crimes has increased over the years. And the pair 2 test for robbery, similarly, in this case, though, the p-value is greater than alpha 0.05, so we cannot reject the null hypothesis of no difference. And the confidence intervals, one of them is negative and one of them is positive. So in 2015, the confidence interval was negative, so the number of robberies increased over the years, and in 2016, it decreased since it's a positive value. So the lower value is the smallest value we would think is possible for the difference in averages, whereas the upper value is the largest number we think is possible for the differences in averages. And once again, the negative CI represents an increase in crime, and the positive CI represents a decrease. And lastly, I did regression of motor vehicles 2016 on motor vehicles 2015 and their region. So first, I started off with this test, but then to make it more simple, we used the round command, but then did the ANOVA, and the ANOVA test tells us whether or not there is a region effect on this data, and since the p-value is so small, there is actually a significant region effect that is taken into account in this data. And that is it.
Great, thank you. Any questions for Courtney about the data? It's an interesting data. Was there something about, so picking these two variables, was there something about these two that was particularly interesting?
I tried to pick the ones that had like the bigger difference between the years, but a lot of them were actually pretty close. So then I just picked some that were more interesting to myself.
Yeah. Good, thank you. So maybe some of you, I'm a little bit behind in grading, so I'll figure out if some of you also did that. Did that one, maybe had some other things, or did other data sets, but great. So at the end of the course, or instead of having a written final, everybody will do a presentation on their project at the end of the time. Right? And so this was one of the presentations for the student projects, and so there's a couple of you that are remaining. So Mara, right, you still have to go, and Annie, right. And so I'll check the schedule and think about topics for that will fit in with what we're going to do. Good. So a couple of things today. One a little bit different. So there has been some messages from the president about things on campus relating to racism, right? And bias incidents on campus, and so we've certainly been encouraged to give it an opportunity to discuss these things and how it might impact things either in the classroom or outside the classroom, and general feelings about how things go, right? So this is a more technical class. Some classes would be directly engaged talking about diverse identities and societal issues, history and societal forces and things. And so those might seem more focused on that. But it's worth talking about it in this class too. And there's different ways of talking about this. One is for you to share anything you'd like to share about that. Does anybody want to make an opening statement about what they know or perceive, or ask any questions that they might like? I might not know much more about the campus than you do, because it's, the president is being very open in broadcasting information. Other details probably are public safety and a few groups and things like that. But so over the time that I've been at St. Michael's, there have been a couple times that apparently outside groups have posted, white supremacist, inflammatory notes on our campus, University of Vermont, Middlebury, other places. So it doesn't appear grounded here. And that it's not just, Vermont. It's nationwide. There are groups in different parts of the country there. Back in the 1980s, with the first farm crises, and the loss of family farms, there was a rise in white nationalism out in the Midwest. Well, there's a perceived, there was economic displacement, and some people attributed that blame to certain groups. And so there are these currents and forces within society. So, my, opinion on this is, that racism exists. Sometimes it's explicit, like doing these things. Other times it's more implicit, how you treat people, how you interact with people, we talked about that Pygmalion effect as an example, and so that comes through how do you interact with other people and so on. So I think it's our obligation to oppose racism and other biases and work within ourselves and society to oppose that, to reduce that and remove the bias, right? And so in life it's hard to know what to do, right? You can certainly try to do your best in interacting with people, but do you make much of an effort to go out and get involved in other cultures, learn about other parts of the world, have friends and acquaintances and activities that will expose you to a broad thing, right? Sometimes it's easier just to do what's easy, right, in terms of what's familiar, and sometimes it takes a little bit more of an effort. But many times it can be very rewarding to have the broader interactions, and so certainly in raising children, I try to give them that perspective that they should have friends of all different types and be open to any different types of circumstances. I felt growing up, we were living in Maryland before being here, and that was really quite diverse, right? Where the schools would be, 20% African American, 20% Hispanic, 20% Asian, and so it was really quite a significant mix of individuals at all different levels, and somewhat less economically diverse in the area we were in, but it was economically diverse in the immediate community, right? So you can work on it within yourself, but then what do you do in society? Do you go out and protest on the street? Do you, say something when somebody else says something and speak up? And also, do you conduct your professional life, in a way that would kind of minimize bias and be more equal and things like that. So these issues of racism and bias certainly have affected statistics, right? So there's kind of the personal statement, but then there's this kind of professional side of it as well. And in terms of the professional side, there's so there's personal, right, and professional. And so I've kind of talked a little bit about the personal side of that. And if anybody wants to say anything more about the personal side, we can talk about that, or if you'd like, I'd be open to talking to any of you in office hours or in private about things. One of our math majors from a couple years ago, Sophia Adams, was very much involved in student government and was very involved in activities, Black Lives Matter and things, and so attended many of the events, and so I saw a number of the things that were going on through what she was doing. So it's very possible for somebody in math sciences to be involved in those activities as well. Professional, in terms of professional things, within the statistics, I think statistics and science in general has made a lot of gains in terms of points on this, right? So things like clinical trials and research. Clinical trials now are focused on including all races, ethnicities, genders, ages, abilities in the research. NIH, National Institutes of Health, for their funded research, you write out an inclusion table of what race, ethnicities, and males and females, by adults and children that you're intended to include. So it's very explicit that you're supposed to do that. And if any research is done, I've been on review boards where things have been proposed and it's one population, like it's one medical center. And there's significant research with the Mayo Clinic in Minnesota, but doing research in just one location, you tend to get some areas of the country more one race ethnic group represented and the others are very smallly represented. Many studies are multi-center across different areas, and so they explicitly include groups, centers in the South that might get more African American, or the Southwest that might get more Hispanic, and or California or New York, the major metro areas, will also get larger Asian populations. Right? And there's some research, like the Diabetes Prevention Project that was at George Washington University, that made a big point of saying that we have included a diverse population in the study, and therefore it's better research. It tells us more about those groups, and it tells us more of what the average effect would be across the entire United States. Right? There's more protection for vulnerable populations. A lot of research looks at, you can't give big economic incentives to poor people to get them to participate in research, because that could be viewed as coercion. If you're going to pay them $500 to do something dangerous and they don't have much money, that's not, it's a little bit too much pressure. Right? Certainly prisoners are in a vulnerable situation, but elderly, disabled, and then some minorities in certain groups, areas would certainly be vulnerable. In general, the major statistical societies have published things on ethics. So ethically, how do you conduct research and do statistics? So American Statistical Association, International Biometric Society, others publish their research on what's proper practice, and it includes things like consent and protections for review boards to make sure that things aren't harming patients. But it also includes doing good statistical practice, and that's kind of what we focus on here, right? If you can fit better models, do better statistical work, I view that that's using a better use of what people contributed in terms of data, and so that's value. There's, I don't know what the points are exactly, right? It's still, you could say that there seems to be an underrepresentation of some groups in some of the sciences, right? So for a long time, women have been underrepresented in some areas of science and math, computing perhaps, right? And so the National Geographic magazine, the new issue is on women of the last century, right? Because they have images and stories about women going back, a full century, and they talk about change. And one of the articles in there is, where are the women in science? And the answer is, they've always been there, right? They've always been there doing research. And their numbers might not have been as high because of the way society was organized, but they're there. And so in statistics, they certainly are there in large numbers in government and academics and industry. And certainly many of the departments I've been have had women who have been chairs here at St. Michael's, and directors of the Biostatistics Center at GW, chairs at Iowa State University. But there still are some smaller departments where turnover has been very slow, where the number of women represented in those has been smaller. So there's still, if you kind of look at what's the percent of women in certain departments or areas, it appears smaller, but you kind of average it over the entire field, it's much more equal, particularly in statistics. In biostatistics, majority of biostatistics graduate students for a number of years have been women, right? And so that's reflected at the senior levels of the faculty. So there is a period of change, which things become more open and equitable and attractive. Some people work in the kind of the sociology of professions. Right? Are certain professions viewed as more, high power? Do males tend to go into that, and so on? So are women doing more teaching or more service versus more research or something? And so there are many ways to look at it, and you kind of have to be aware of those. Now, underrepresentation of minorities is another issue. So certainly in my professional career, I've interacted with many individuals who would be parts of minority groups. So certainly at the U.S. Census Bureau, there are many leaders there who are African American. Tommy Wright has been the director of statistics research there for, I don't know, probably more than a decade, right? And maybe two, right? Or at least in the senior levels. So many of the field officers, directors of census operations, and so on that I've interacted with there are African American. The graduate students I've worked with at University of Chicago, other places, professors at Iowa State. So they are there. But that said, the numbers are not that high, right? I know many that I've worked with, but across the spectrum and when I've served on different panels, the percent African American representation has been kind of low. Why is that? Right? Some people point to forces that discourage, some kind of implicit biases that people talk about, that because there are not as many African American faculty teaching, it doesn't encourage other individuals of the similar race, ethnicity, to go into that field. Maybe they don't get promoted as much, as much inside knowledge, much help. So these things could be subtle, right? Not necessarily intentional, but just kind of the system as it's set up might not be quite as good. So there are efforts, scholarships, support at different institutions, and if people make an effort to help everybody, to be more promoting and bring, encourage people to pursue degrees and continue education and go for jobs. In the long run, it can make a difference, but it's not necessarily something that's going to happen overnight. The other thing where that could happen, right? People talk about the pipeline. Right? Where does the pipeline start? Does it start in college when people are doing degrees and then graduate school? Well, the pipeline probably starts in elementary school, right, or before. Right? And so all the way along, if certain populations are going to schools that are preparing them less well for science, or encouraging less well, or seeing role models that are achieving in different areas, it can have a gradual winnowing. So towards the end, where you have the PhD researchers on National Academy of Sciences panels, there's continued underrepresentation. Right? So it's difficult. It's difficult, but if you're aware of that, in your professional life, if you go into teaching or you're mentoring junior colleagues, and some of them happen to be from other groups, then making a special effort to be fair, to give everybody a chance, and if some individuals you give special encouragement to, whether they're male or female or different races, you think that some people really could have a potential if they believe in themselves, then you can do that. A lot of the rest of the statistical profession is very international. So I have co-authors from India and China. They're in the U.S. now, but one guy, Parthil Ahiri, is most of the time traveling around the world giving talks. But when he is in the U.S., he lives in the U.S. And then in the graduate programs in teaching and in the societies, it's extremely international. Individuals from South America, Uruguay, and Chile, and then in Europe, there's very strong international organizations in Spain and Australia, New Zealand, and so it's really very diverse, right? So I kind of lost my points. But my experience at St. Michael's, I've worked with students who are African American, and speak multiple first languages, right? They grew up bilingual, so both men and women, and people from other countries, and I've seen many of them achieve very high things, so that's what I expect. And I think everybody can do that, achieve up to their potential. Research on these topics, let's say, just research on bias in general is, there is research on this, but it's challenging, right? Statistically speaking, it's an observational study, right? You don't randomize people to gender or race and things like that. Some researchers try to do randomized experiments where they take, a resume and give the person a name that looks Scandinavian or something, right? So most likely Caucasian, and then they take the same resume and put a name on it that looks more African American, more typical, right? And then send those out and get evaluations and see, same resumes, different names, is there a different evaluation? And sometimes there is, or is a female versus male name, right? And so that's troubling, right? That would happen, that the same accomplishments would be rated differently. So whenever we go through hiring processes to hire faculty, they review with us. These are the guidelines. You have to be fair. You can't take these things into account. You have to look at the potential for teaching and things like that. So there's some research like that. There are other things. I looked at one database. The National Science Foundation has a large statistical database called CSTAT. So it's a database on scientists and engineers in the United States. And it interviews people with PhDs. I've been interviewed for this. They send me a survey every 2 years. They will for the rest of my life, probably. And so I've probably been there about 10 times or something like that. Right? And so it's this longitudinal database that people do. And because it's longitudinal, if people answer every time through, then you see them, right at graduation, maybe their first job, do they postdoc, assistant professor, associate professor if they keep going, do they leave for industry, do they stay through that? And so you can compare these career trajectories for men and women. And so are they equal? Well, this goes back 40 or 50 years. I think the modern versions of it are back to the 1970s, 1980s. And the survey has changed over time, so it's kind of complex to use, but you do see differences. The differences are narrowing as you get to the more modern era, right? But it has variables like how many professional memberships do you have? How many conferences do you attend? And so on. And there still are some differences, and of course there's great variability by field, economics versus biology versus math and statistics. They're very different. And so it's kind of hard to do that comparison and figure out, is there a difference in what would it really be attributed to. The databases there are really not sufficient to explain what's going on. Right? The real thing you'd want to know is something about activities. Are people publishing? Are people getting, what teaching reviews are they doing? Why do some people get promoted and some people don't? Right? If you look at kind of a certain transition period. Do they get funding for research? Do they have successful students? Right? So there's just so many things that you might want to do. And some people try to do that research. They try to go in and get people's publication records and see where they're publishing. There's different levels of journals. Each field usually has its 2 or 3, maybe 5 premier or top level journals. And if you publish a few articles in those, they're more recognized. Most fields have a dozen or 2 dozen or more kind of secondary journals. They're research journals with review processes, but they're considered not to have quite the same impact. Right? They're not necessarily read by everybody in the field, whereas the top few people that are concerned with that field probably read that. So it's very hard to do that that research. The other way that research gets done is to look into detail at the entire records and try to create variables that capture things. Did people publish? Did they serve on committees? Are they in professional societies? And do they get certain types of honors and things like that? And one colleague I had at Iowa State University when I was there is Alicia Kirkakiri, who was a very senior woman in the profession from Uruguay. And so she did a large-scale study of that. And the way things are now, hiring levels, people aren't hired at different salaries so much based on gender, right? They're kind of, here's the current value we're paying for assistant professors, and you're hiring male or female. And, they're pretty equivalent, right? There was some growth. So where it came down to, once you adjusted for a number of these things, once you selected regression coefficients to put in the model, a lot of apparent differences seemed to go away, right? So if you had more publications, you got more, more higher salary. If you had more students, you got a higher salary. If you had more honors, you got a higher salary. But they also found information on what people were requesting, right? When did people go for promotion? They found that the male researchers, the scientists, were asking to go for promotion a little bit earlier. Right? So the earlier you go for that, then it widens the gap, because there's usually a small salary bump going to tenure or associate professor. And they would ask for more things, right? They would ask for their request for office space or lab space was a little bit bigger. So what is going on with that? Is there a cultural thing where men feel like they can be more aggressive with asking for things or pressing their case? And is that a culturally accepted practice? That's just that's the way it is, and people don't have to worry about it. But do some researchers, whether it's women or minorities, feel like I can't push too hard when maybe they're the ones that have the greatest talent? And so subtle things like that are a little harder to figure out could still be there. But I think the institutions have, so it's a difficult statistical problem to think about. It's a difficult social problem. But I think the time now is really ripe for making progress in terms of equality and equal opportunity, because the scientific endeavor, research endeavor, and society in general, I think, will benefit the most with equal participation by everybody, and taking the best people across a really diverse set, right? And so will help things in the long term the most, right? So it's a challenging issue dealing with any type of bias in evaluating students, in evaluating employees, and just generally progressing in society. And so unfortunately, some very negative aspects, trends in society come out now and then. Others experience more subtle ones on an individual basis. And so it's something that affects every place in a nation, not just St. Michael's. But if we're willing to talk about it, I think it can make it a better environment for everybody. So, but any comments or thoughts? Yeah.
I guess something that I've had a couple courses that I've talked about kind of on this topic related to statistics, as well as kind of things related to like machine learning and data sets. And a lot of times the data sets that these things are being trained on have implicit biases in them from when the data was collected. If we're using a data set from 20 years previous, and that contains implicit biases or underrepresented groups because there wasn't these things in place, we're creating these things that carry on these biases. And we think of like computers and statistics as like objective, but
Right.
a lot of these things are being like carried through. One thing we were talking about in my classes is like self-driving cars are becoming a thing, and they're more likely to hit a person of a minority than
Oh, really?
a white person. Yeah. So like, and it's just because of the data sets they've been trained on.
Uh-huh. So in terms of, the car sensor, does it recognize people differently, or is it, just walking pattern behavior or something like that? Or-
I'm not sure all of like the bases on it, but
Yeah.
like most of self-driving cars have been primarily tested in Silicon Valley,
Uh-huh.
where there isn't as much diversity.
Yeah.
And so the cars just haven't been trained on.
Yeah. So I mean,
populations and-
a heavier urban environment,
Yeah.
right, with more people walking, more pedestrians, right? Take a self-driving car to India, and there's cows and
Yeah.
and animals and just pedestrians and carts and things. It just, it wouldn't work at all. It wouldn't probably be able to move because there's too much congestion, right? But yeah, no, that's true. So there was a book that I ordered, and it's in the library. I can't quite remember what it was called, but about data science and police forces, right? And so certainly, where do the arrests happen? Well, it happens where the police are, right? So if the police are in certain neighborhoods checking on things, they're going to find a higher percentage of crimes and things like that. Or where do the stops happen? The police are going to stop people where they are. So if they stay out of certain neighborhoods and don't you could say bother them or don't patrol them, then there's going to be less arrests. So, but if you have a database that says where have police stopped people, and they've been in minority neighborhoods, then the database is going to say go to minority neighborhoods, right? And so getting other predictors of crimes, right? Because you really want to use the predictors of crime to make things more efficient, figure out where there's drug activity and so on. But having that separated from targeting minorities, because past decisions have created some bias, is tough, right? Which variables to use and which don't you use? The whole field of employment discrimination. Are you discriminating based on race or gender? A lot of it comes down to do the people you're comparing in this non-randomized study, are they similar or not? And what experiences do you look at? Years, training, ability, performance reviews. There's been a couple instances I know, at different departments where people didn't really do that effective performance reviews, right? And then there was a problem, right? And so when it came time to say, look, you really shouldn't be promoted because you haven't done very much, you haven't quite met expectations, they said, oh, but my last 5 performance reviews, everything was fine. Well, there's kind of a problem, right? So if the kind of evidence that they might give or have is that if that evidence isn't generated and isn't really that meaningful, it's hard to use it for prediction or evaluation. But yeah, so the data sets can have historical biases in them, and trying to predict human behavior is very hard. So sometimes people think about getting a proxy for some factor. So to what degree is crime associated just with poverty or unemployment, or rental housing or low-income housing? That not necessarily race associated, you're not necessarily focusing on race to do that. That might be a predictor of certain areas but it runs into the same problems. You don't necessarily think all poor people are bad, but what could you use? So some balance there is difficult to do. That said, if police can use a sources and methods to detect patterns, I think they have used it successfully to identify areas where there might be crimes, perhaps series of burglaries, kind of patterns to look for, and so, or associate things with individuals. So there's some potential, but some challenges of doing it and being fair to people in society. So, any other? Yeah.
In addition to Maura's point about the self-driving cars, there's a lot of other like predictive models that have biases ingrained in them. Thinking specifically of like recidivism predicting models and like hiring algorithms. And I'm wondering if you've like seen that in like the profession of statisticians, and if you've seen like a shift to account for that like ingrained bias in algorithms and models.
I don't know about particular research that might be, looking at that, but if it's, I certainly believe it. Something like that could be true. Many hiring models, like what the Gallup organization. So actually, when I grew up in Lincoln, Nebraska, and there was a small company there called Selection Research, and one thing they did was personnel selection. So you want to hire salespeople or hire interviewers or something like that. Well, how do you do that? There are a bunch of psychologists from the University of Nebraska who, had scales, interview scales to bring out people's talents. And they would interview the highest performing individuals and see how they performed on those scales. And they'd interview people and score them. And if they looked like the best performers, then they got preference for hiring. Well, if some of those behaviors or attitudes are typical of one race ethnic group, then kind of unconscious, unwittingly you'll be reproducing that. And so it's just, a simple prediction model, but they were very successful at that and eventually bought the Gallup poll. And Gallup now is, several $100 million company, but anyway, so some of those models, depending on what they're built on, might seem perfectly reasonable, but I think you would have to re-examine that from time to time and what is the mix of people. So looking at other ways of measuring performance and other data sources to predict it. So if you try different statistical models, different data sources, you might get different predictions, different classifications, and try to do that. In terms of the statistics profession, and so hiring at the university, you're instructed not to talk about people's ages when you're talking about their evaluation. You're not supposed to discount somebody because they're older being hired for a position. You're not supposed to talk about whether they're married or have kids or certainly not race, ethnicity, or gender, right? You're not, and you're supposed to not. So we're instructed, and then some places have an equal opportunity employment, advisor put on hiring committees so that they monitor what people are talking about and thinking about to try to influence them to be more open. So that is part of the process. One place that has championed equality has been the federal government. So it's the federal requirements on not discriminating, and so individuals with disability or minorities or other things that might have encountered more bias in business or society in general. So I think the federal statistical system is fairly diverse in terms of its employees, at least what I've seen. And then that is translated into middle management and upper management and kind of very senior leadership. So I don't know if that completely addresses your question, but it's kind of along those lines. But I agree. It's if you develop something based on historical data, looking carefully at what does that data mean, and are certain patterns going to be there that are, so if you found a pattern that was associated with race, ethnicity, and then that, it's a hard discovery process. And then thinking of alternatives, that would be, look at what data is available. Can you make it so force that everybody does a more equal comparison of the data that's there, right? Or that you could get, maybe to think of new data and new ways of expressing things. Maybe getting a broader input on people's performance, right? If you get that one-on-one interactions, if one person is rating this and this one person has a bias against a certain group, then there's a lot of jeopardy because there's only one, it really can have an impact. But maybe if there's broader input or greater set of measures and oversight, then it might be able to counter some of that. But anyway, I think it's important enough to spend a little bit of time on that, and it's certainly a much broader question that we can take up fully, right? But anything else, right? So we can talk about a statistical topic. The statistical topic that we can mention before the end of today. So the next topic that we were going to do is in this chapter 13, right? There's mention made in the book of blocks as random effects. So the way that this goes is we have some outcome, y, and then we have some treatments, different levels of treatments, I going to say 1, 2, I, and then we have blocks. And in a complete block design, you'd have at least one copy of every treatment inside of each block. And so the outcome, K, indexes individuals or units. And there's some intercept, there's some impact to the treatment, there's possibly some impact to the blocks, and we're going to look at just the additive model in this case. And so there's some block effect, right? And sometimes the blocks are just part of the design, right? Like in the sea grazers, you're going to go down a certain depth or to a certain location and set up the monitoring stations. And so you just put a bunch of treatments together, and it's more efficient to just kind of put them there together rather than randomly scatter them completely over the ocean floor. But you might, and in that, sea grazers are probably interested in those blocks because they have biological meaning, right? But in other cases, the blocks don't necessarily have that much importance to us, right? So in one example, in the manufacture of penicillin, the source material is used to make 4 doses. And there are 4 ways of making the penicillin. And so because the source material can be used to make those 4, the different source material becomes a block. Or you make the source material, and there's some variability in its composition. And so each batch of the source material is a block. And there's 4 ways of making penicillin. Those treatments, A, B, C, and D, are the treatments that we can compare. And so very naturally, by the manufacturing process, you get these blocks. But you're not necessarily really interested in each block. The blocks are more sampled from a population, right? It's as you're going to do this repeatedly, you're kind of random selection. So it's possible to think about the blocks as a random effect. So in the model, right, the EIJK has its normal error, but the blocks in a random effects model are also thought about as random from a population, right? And so random effect for blocks. So the beta J for the blocks. Those things can be given a normal distribution as well, with some variance. Right? So there's some effective blocks around there. Right? And so the overall model is called a mixed effects model. Right? Where there's a fixed effect for treatment. But then there's the random effect for the different blocks, right? And so it has some components like that. And so in these randomized blocks, sometimes data are analyzed accounting for that, right? And sometimes it makes a difference. So the example that's on here, just to do a short example on that, there's a book by Julian Fairway, right? So this is in a book, extending the linear model with R. So generalized mixed effects and non-parametric regression. So it includes some things for random effects. That would be an appropriate book to read after this class. Maybe that'd be used for another class. Possibly, if it's particularly interested, some of the details in that book could be used for a project to do a little extension. But one data set they have on there is this penicillin data. This is the data set. There are 4 treatments, and there are these things called blends, are the mixtures of the source material that go into making that. There were 5 of those used, and each treatment was put onto each blend. And then a yield of the amount of penicillin that's useful is there, and the question is, do those vary by treatment? But of course, blend is just part of the manufacturing process. You're not necessarily going to ever repeat that particular blend, right? Because it's kind of, you manufacture it and it comes out a little different every time. So it's really kind of a sample from the population that you might use in the whole process. But it affects variability, so it's good to use it. You could do attach, and that's the one. So if we do a box plot of yield, function of blend, does it vary by blend? So yeah, it looks like there's a fairly big impact by blend. So it'll be good to have blend in the model because it'll affect some of the variability. Overall, does it affect? See that there's a treatment. Some difference in treatments, like this C seems to be higher and A maybe is lower. Right? Kind of similar variance across those. So one way of, here's a little summary of that. One way of analyzing it would just be as a fixed effects model. It's an effect for a coefficient for every blend and a coefficient for every treatment. And if you summarize that model, you get some significant effects of both the blends and some significant effects of some of the or not quite significant. I guess the treatments are not quite significant overall. So the blend, though, is that the treatments these pretty small sample sizes. Right? So if these were each based on 1,000, then it probably would be significant. But they're based on 5 each, so pretty small. analysis of variance model, there's a significant effect for blend, but treatment effect is not quite significant. And these are the coefficients that come out. So what's the predicted average for treatment A in the first block? Well, there's 90. Right, this is blends. In the first blend, you get an average of 90 and different treatment. Now, there's a way, we haven't talked about it too much, that R computes the estimates. Right? There's different ways you can do contrast. Right? You can estimate and intercept the value for treatment A in blend 1, and then everything else is a difference from that. Kind of set the effect of this as 0 difference from that, its average, and then everything else is different from that. And that's essentially what the first part did. That's kind of a treatment. There's something called contrast for how it figures those things out. And this first one has an impact on what coefficients we're actually going to get out of here. If you look at Faraday's book or some other sources, they like to do this other contrast, a sum contrast, so that the sum of all the differences add up to 0. Right? So it means that the first one is not necessarily going to be 0, and it means the intercept is going to be kind of an overall average. Right? So if you change those and run the linear model, you get different coefficients here. You get 86 for the intercept. Blend 1 adds 6 in, so that's up to 92. And treatment 1 adds -2. Right? So that's back to 90. So it's the same values, just but parameterized a little bit differently. The goodness of fit and these residual standard errors and all this is still the same. There's no change there. The analysis of variance table is going to be exactly the same, but it's just a little change in how those things, the coefficients are represented. You can fit this mixed effects model. If you think of the blends as random with this command called linear mixed effects regression model. It's in a library called LME4. So you have to attach that, install that, and then do library of that. And then you get this command. And so yield treatment is a fixed effect, and then it's random within levels of blend. Kind of how you might read that. The data set is penicillin, right? So this does this linear mixed effects model. You can fit it with maximum likelihood, or there's something called restricted maximum likelihood that's sometimes used. It estimates a couple of variances. Right, this should be the mean square error. Well, it's not necessarily exactly the same as the other one, but probably pretty close. And a variance is of the blends, which is pretty large, right? The variance of the blends is pretty large there. It gives the estimate of the fixed effects, types of treatments. These are the same as before. I didn't give p-values there, but you could do those. There are. And it gives estimates of the blend effect. These are a little bit different than the effects before. They're a little bit shrunk towards 0. That normal assumption on the errors pulls them in a little bit, which can be nice if you happen to get kind of an extreme value that you don't want to estimate it so far out. Maybe it should be back there. And it can do analysis variance to test for the overall effect of treatment. And it's kind of the same conclusion, whether you do it as fixed effects or random effects. And so you get it's not significant. But although, graphically they kind of appear different, it's really based on small sample sizes. So it doesn't really prove that the different ways of making penicillin yield different amounts, right? So that's a little bit more on chapter 13. There's more to do with the random effects, and if you went on into higher level models, you might do more with that. So, kind of a mixed day today, right? Presentation, the statistical about, but basically a discussion about racism on campus and in general in the profession. And so, at some time, if there's an interest in taking up more of that conversation or having individual discussions with me about that, I'd be glad to do that.
have a good weekend.